and also on YouTube. Today's subject, gout remission, and whether or not you want to consider the drug allopurinol. And we're going to start right now. Now, before we go down the road of gout remission and whether or not you want to consider the urate lowering drug allopurinol, I want to let you know that if you're interested in a finger stick machine in order to quantitate your uric acid. We have a deal offered by urate. Sure, there's a code for that in the show notes of my on my YouTube channel, and there will be a coupon code there, and you can pick actually the new meter up. This is the older one, but you can get the new meter for some percentage off. And then secondly, we are offering a really amazing gout remission online course for half off right now. The link for that and also a coupon code is also in the show notes. Now let's get on to today's topic. And by the way, for those of you that are listening right now, if you have questions, go ahead and type them into the chat and I'll get to them. Usually, the usual way that I do the live show is that I have a set of slides that we run through, and then I take questions at the end. So the question today, and this has come up a lot, and the reason we're talking about this is because I've had a lot of people reach out to me and ask about urate lowering drugs. And so I want to just talk about what my process was to consider this. And in doing so, we're going to talk a little bit more about the gout hypothesis that I recently also discussed with Dr. Richard Johnson. And then we're going to talk about the difference between intracellular uric acid and extracellular uric acid. Extracellular uric acid being the form of uric acid that we find in the circulatory system. And then we're going to talk about, personal considerations you want to make in terms of whether or not you utilize the effects of allopurinol. So the first thing is, remember, I'm not a medical doctor. I have a PhD in biochemistry, and I'm also a nutrition network coach practitioner, not a medical doctor. So I'm not giving you medical advice here. I'm going to tell you my story, and I'm going to lay out the science behind why I made decisions that I made. And then maybe this will help you decide about your own metabolic outcome. So the first thing is the standard gout hypothesis. If you go to a doctor and ask about this, or even a gout center that you could find in your town, what they're going to tell you is that gout results because of an increase in uric acid in the circulatory system. This diffuses into the joint where it can crystallize, and in the joint, when it crystallizes, much like a sliver in a finger, this is going to draw in the innate immune system, and kablam, you're going to have a gout flare. The problem with this hypothesis is I believe it's a false narrative, and we can see the first clues that it's incorrect if we just look at the statistics of gout. So we're going to review this. I've used this slide before in some of my presentations. About 4% of our population, that's somewhere between 8 to 9 million people, are gout sufferers. Now, the important thing to realize about this is that there's somewhere between, and I say between, 68 million and 43 million people, because there's a couple of different epidemiological studies or associational studies that pick on a different number. So somewhere between 68 million and 43 million people in the US are hyperuricemic. That means they're walking around with high uric acid, but the majority of those people do not suffer from gout. So that is the first clue that although uric acid is required for a gout flare, it is not sufficient on its own. We can also push this further, and we see that for the mean concentration of uric acid in a gout flare is about 8.3 mg per deciliter. And for example, in 2016, when I was diagnosed with gout, the concentration of uric acid in my blood was 8 mg per deciliter. This is at the top of the reference range. It's not outside it. And the reference range goes between 4 mg per deciliter and 8 mg per deciliter. So quite often, the concentration of uric acid in a gout flare is within the reference range. And we can see that when we look at the numbers even more closely. A full 18% of gout sufferers will have a uric acid value that will be between 6 and 8 mg per deciliter. And literally 14% of gout sufferers will have a uric acid value that is under 6 mg per deciliter, or well within what's considered the normal range for uric acid in a human. So the question becomes, what in addition to the uric acid is required for a gout flare? And that's what we're going to focus on right now for the first part of this presentation. And we need to do that because as a gout sufferer, I want to make lifestyle changes. I want to make metabolic changes based on the best information I can get in order to get results. The last thing I want to mention here is that if we look at hyperuricemic people that don't have gout and we stick a needle into their joint and draw out synovial fluid, you can find crystalline uric acid in their joints. So again, this just more or less taps off what I'm talking about here. Uric acid is required for a gout flare, but the current hypothesis that we have high uric acid in the circulatory system, that uric acid diffuses into the joint where it crystallizes like a sliver in the finger and then causes the gout flare. This is incorrect because we know we can find crystalline uric acid in the joints of people that don't suffer from gout. So while uric acid is required for a gout flare, and this is the key language, it is not sufficient. So what do we know that would allow us to think more scientifically about what's going on in the joint of a gout sufferer? How do we get to the gout flare? And I almost forgot. So the other thing is, if you are a gout sufferer, one of the key things about this to realize is that gout is not an individualized illness that happens separate to anything else. It is connected to metabolic syndrome. And you can see this when we look at the statistics once again. A full 74% of gout sufferers are also hypertensive, so they have high blood pressure. 71% are suffering from chronic kidney disease. Over half are obese or significantly overweight. A full quarter are also suffering from type 2 diabetes. A large number of them have kidney stones, which are sodium urate crystals, and then a significant portion are also suffering cardiovascular disease. And gout sufferers often will have more than one of these ailments, all as a constellation together. So this suggests that there is a unifying central mechanism that's driving these chronic diseases, including gout. So a gout sufferer needs to look at their metabolics very carefully, because even though they're suffering from gout, more than likely some of these other conditions probably exist in their situation. So what is the central mechanism? And the gout hypothesis comes from the fructose uric acid model of diabetes, obesity, cardiovascular disease, and by extension gout that has been proposed by Dr. Richard Johnson's laboratory. There's literally decades of published work here, somewhere in the order of greater than 700 publications. And right now you're looking at a diagram that illustrates this process. So in the standard American diet, we have the standard American meal. And if we talk about dinner in particular, it's likely that there are 3 conditions that are true about that meal for many people. Number 1 is the presence of alcohol. Number 2, we have added sugars because of processed food. The added sugars are going to include any and more than one option in the case of table sugar, which is 50% by weight glucose and 50% by weight fructose. It could be high fructose corn syrup, which is a mixture of the two molecules, which means that one or the other can be present in unequal amounts because the food processors have mixed those two molecules together into the mixture. And usually the high fructose corn syrup is about 55% fructose compared to the glucose or more. Then we have the agave syrups that can be literally on the order of 90% fructose or more. And then we have the added sugars that are in processed foods, which constitute literally about 74% of what you find on the racks in a supermarket. So when we think about the dinner meal, and the reason that I want to do this is because it's an excuse for me to talk about the combination of the alcohol along with these other two effects. One of those effects being a high load of fructose, and the other effect, a hyperglycemic meal. So during the dinner on a standard American meal, we have potentially a large alcohol load, we have a large fructose load, and we have hyperglycemia, a hyperglycemic event because of hyperglycemic foods, things like rice, potatoes, and again, potentially sugar, for example, in the sauces and so on. The fructose uric acid model is a situation where when we have what we call the deadly triad, and this would be the alcohol, the fructose, and the hyperglycemia, this activates fructose metabolism. And what makes fructose metabolism unique is the fact that it is metabolized in an unregulated and uncontrolled manner. So the whole load of fructose that shows up at the liver, and we're going to just talk about this on a general basis on the liver for now. So that whole load of fructose is showing up at the liver. All of it is going to be transported in, and then all of the fructose is going to be phosphorylated by an enzyme called fructokinase. And as a result of that, you can see in the first step here that ATP is hydrolyzed to ADP. And because all of the fructose is converted into fructose 1-phosphate, we see in the liver a decimation of the supply of ATP, a decimation in the supply of phosphate, and we have a sudden acute rise in uric acid. And this is what's driving systemic inflammation, dysregulation of the nitric oxide pathway. In the systemic inflammation, we have activation of a protein called JNK1 and a cytokine called IL-1 beta. Both of these proteins are sitting at the top or the pinnacle of the inflammational cascade. And there's one other thing that I'm forgetting. So we have, let's see, three things. We have the systemic inflammation, nitric oxide dysregulation, and then the mitochondrial dysfunction. So essentially what's happening there is the liver is being reprogrammed into de novo lipogenesis, or the production of fat and oil droplets literally right in the liver. And some of that fat is delivered, is shipped out of the liver in what we call VLDLs into the circulatory system, where they can make their way to the adipocytes or to the fat tissue where where that fat is going to be stored within the fat tissue. As a consequence of this pathway, we have an increase in hunger during the meal. So we're going to automatically overeat, and we have an elevation in cravings. Now, just for a moment, if we go back to the alcohol and the hyperglycemia, the alcohol is going to activate an enzyme which is called aldose reductase. And the function of aldose reductase, because we have a hyperglycemic event, the glycolysis pathway in the cell is completely full, and we have pooled glucose at the front end of the glycolysis pathway. And aldose reductase is an enzyme that's responsible for shunting that glucose into endogenous fructose. So the effect of the alcohol is to actually activate that enzyme, aldose reductase, and to enhance the shift in glucose to endogenous fructose. Similarly, aldose reductase is also activated by hyperglycemia, the increased pool of glucose sitting at the top of the glycolysis pathway. So we have the polyol pathway that is driving fructose into endogenous, or driving glucose, into endogenous fructose, which is then broken down, and we get the sudden acute rise in uric acid. And again, this is driving the systemic inflammational cascade with JNK1 and IL-1 beta. It is causing dysregulation of the nitric oxide pathway. By the way, this pathway that we're talking about right now happens in the endothelial layer of the cardiovascular system. So everything that we're talking about right now goes on in the endothelial cells. So we have the uric acid disrupting, increasing that systemic inflammation, disrupting the nitric oxide pathway, and shutting down the burning capacity of the mitochondria. Now let's turn to the joint and review what's happening there. So one must understand that whatever the circulating amounts of glucose and fructose and uric acid is in the circulatory system, they will enter the synovial fluid of the joint. This is the fluid that bathes the specialized biological cell called the chondrocyte. These small molecules will enter the synovial fluid by the laws of diffusion. And what that means is that the synovial fluid itself is going to have comparable amounts of glucose, fructose, alcohol for that matter, and also uric acid. Now, in the fructose uric acid model of gout, I am proposing that we have a similar scenario in the chondrocyte as we have in the liver, the brain, or the proximal tubules of the kidney. And that is that firstly, the chondrocyte is existing in the joint of this person who is on the standard American diet for perhaps decades. Like this was my case, right? Because I'm 63 now. And when I was diagnosed with gout, I was in my late 50s. So you're talking about someone on the standard American diet for many decades. This results, and there's good science behind this, in low-grade inflammation in the chondrocyte. So the chondrocyte is primed. It already is producing JNK1 and IL-1 beta to a certain extent. And then we bring in the deadly triad, that specialized meal where we bring all these factors together at the same time: a high load of alcohol, a high load of fructose, and a hyperglycemic event. This triad then pushes the chondrocyte over the threshold because we get the sudden acute rise in uric acid because of the fructose, the potential of the fructose metabolism within the chondrocyte. The chondrocyte is sick, maybe even cell death. We have the movement of monosodium urate from the chondrocyte into the synovial fluid, along with IL-1 beta and also vesicular ATP. We recruit the innate immune system, which includes the possibility of the macrophages and the neutrophils, and boom, we can have a gout flare. And that's summarized here in a more simple diagram. So again, in the chondrocyte, we have an ailing chondrocyte under chronic inflammatory conditions, which we see, for example, there's a lot of science in the area of osteoarthritis along these lines, that people that are submitting themselves to the hyperglycemic event in a chronic way in the standard American diet have chondrocytes which are being submitted or existing in a realm of low-grade inflammation. Then we bring the deadly triad in and we push the chondrocyte over the edge, potentially to cell death. We recruit the macrophages and the neutrophils as an example, and boom, we can have a gout flare under those conditions. Now, I'm going to segue to the issue of the allopurinol in a series of steps. So I want to point out to you that at the beginning of the presentation, we were talking about extracellular uric acid. When somebody finger sticks, right? For example, if we finger stick with UA meter as an example, we're measuring extracellular uric acid. And at the beginning of this presentation, when we were looking at the statistics, we were talking about extracellular uric acid there. So let's just bring the gout hypothesis together into three statements. So we're talking about the elevation of intracellular uric acid, a sudden acute rise, which causes the chondrocyte to be sickened significantly. We have an inflammational event that happens within the chondrocyte itself, and then we recruit the innate immune system. This is the idea behind this hypothesis of gout, which is consistent with the data and consistent with the statistics that we see for this ailment. Okay, so what does a gout remission outline look like? And remember, right now, we are talking about creating a nutritional program that goes directly to intracellular uric acid. That's what we're after. And the reason we're after that is we want to lower the inflammatory cascade. We want to bring JNK1 down, and we also want to bring IL-1 beta, that expression, down. We want to eliminate the low-grade inflammation that is happening in the chondrocyte on the standard American diet. We want to bring that down. We want to end it if we can. And then additionally, I'm advocating for a low-carb lifestyle. And the reason there is because we are going to bring down everything I just talked about. So we're going to limit the inflammatory cascades, right? We're going to bring chronic inflammation down. But because we've lowered the carbs and we've also lowered the insulin expression, we will increase the capabilities of fat burning in a particular individual. And this will result in the formation of small fat molecules called ketones. And in particular, what I'm interested in is the production of beta hydroxybutyrate, because that particular molecule has been shown in the literature unequivocally to inhibit the inflammatory process that can give you the gout flare. It tamps down on an inflammasome we call the NLRP3 inflammasome. So again, when we talk about this nutritional program to lower the carbs and bring the inflammatory cascade down, we are talking about doing something to drive down intracellular uric acid, the intracellular production in the liver, in the brain, in the kidneys, and also in the chondrocyte. So when we talk about allopurinol, we need to recognize that we're not talking about intracellular uric acid in the sense of the chondrocyte. We're talking about extracellular uric acid that is in the circulatory system. And so you can argue that in the human body, we have two kinds of uric acid. We have the intracellular type, which is a pro-oxidant and is involved in what Dr. Richard Johnson would call the survival switch. The difference between whether the cell is in the fat-burning mode or whether the cell is in the storage mode, whether or not the mitochondria is functional or whether or not the mitochondria has been shut down, whether or not there's de novo lipogenesis going on, whether or not the inflammatory cascade is operational. And then we have the extracellular uric acid, which based on evolution and many published studies has antioxidant effects. And the antioxidant effect of uric acid can be up to 50% of the capacity of our circulatory system. So there is an antioxidant functional aspect to extracellular uric acid. The question is, what is the threshold? Because the reference range of uric acid is going between 4 and 8 mg per deciliter. And many of us, when we go onto the ketogenic diet, over time, we will see our circulating uric acid drop down into the reference range. But many of us, that uric acid drops down to the top of the reference range, a value between 7 and 8 mg per deciliter. So one of the questions for which there are no good literature answers is, what is the threshold of uric acid, extracellular uric acid, in the circulatory system? We evolved to have this antioxidant system. So what is the threshold? How much of it would we call normal? What do we need of that uric acid threshold to be in the circulatory system? This is a valid question for which we do not have an answer. So then the question becomes, do I take allopurinol or not? And so this question is in reference to individuals who are like me. I've been on the ketogenic diet now. I'm in my 4th year. I have 3 years behind me, and I've tracked my uric acid by finger sticking to an extreme degree. And I know that my uric acid concentration on average is between 7 and 8 mg per deciliter if I'm untreated with allopurinol. The question is, should someone like me go on allopurinol to drop the circulating uric acid lower, put it somewhere down well within the normal range or accepted normal range of uric acid? This is the question. And it's a question that, if you're like me, you put your gout in remission, you've been successful with the ketogenic diet, and yet you find your uric acid is still riding high. What is it you want to do about that, if at all? It's a personal decision that you're going to have to make. So let's take a look at what my results look like. And I've showed this slide before. So you're looking here at essentially 3 years of uric acid results. The blue dots are what my first year of uric acid looked like on the ketogenic diet. And you can see, as expected, when we first go on the ketogenic diet, we see an increase in uric acid into the high range because we were producing the ketones initially, right? And the ketones are organic acids. They compete with the uric acid at the level of the kidney to be excreted into the urine. And so the uric acid rises for a time. And you can see in 2020 that there was a natural shift downward. I was not taking allopurinol at the time. And this is reflecting the fact that I became keto adapted. And it took, in my case, over a year for that to happen. But once it did, then my uric acid came down. And you can see when you look at it that my average value is at 7 mg per deciliter. And there are quite a few higher values in that. This would be the black dots. And then in 2021, and to be fully candid here, I've been on allopurinol. I came off allopurinol, and then I went back on it. You're looking at, with the red dots, you're looking at the first time that I went onto allopurinol, and you can see that I effectively was able to pull my extracellular uric acid down in essentially by what would amount as a full unit. So now I'm between 5 and 6 mg per deciliter. And recently I went back on allopurinol, and my average now is between 4 and 5. So the question becomes, why did I go on it? And this has to do with the fact that there's really a big argument out there among doctors about whether or not we should be concerned with uric acid levels that are between 7 and 8, and then sometimes higher, because they do fluctuate. And the question is, what is the uric acid doing? All right, well, we know it's an antioxidant, but the one thing that nobody knows, right? There's actually 2 things that nobody knows. Nobody knows if running those high uric acid levels is actually not healthy for us. Are we courting cardiovascular disease? This is a valid question. Secondly, nobody knows what the proper threshold is, right? there's certain amounts of data that we can go back to, like in 1920, the average uric acid in a male was between 3 and 3.5, yet now it's between 6 and 7 for somebody who's not considered hyperuricemic. Hyperuricemia starts at 7. And for many of us, I'm repeating myself, but for many of us that have gone on the ketogenic diet and are successfully keto adapted, our uric acid remains between 7 and 8, and then sometimes higher depending on what we're eating, other lifestyle factors like sleep and exercise and so on. So the question then for you, and I get this a lot, people reach out to me, well, Dr. Pete, what do you think about allopurinol? So my answer to that is, first, remember that allopurinol is not a drug that is attacking the gout problem, right? This is not a drug against gout. You don't take allopurinol and never have to worry about another gout flare. In fact, a lot of people have gout flares when they go onto allopurinol, and you're listening to one of them right now. When I first went on to allopurinol, I had a gout flare, and my average uric acid was 4.5 mg per deciliter during that flare. What allopurinol functionally does is inhibits the enzyme xanthine oxidase primarily in the liver, the target organ, which is the liver, which causes a reduction in what you see on the extracellular level. So the allopurinol is not a drug that is effective against gout. It is effective at lowering extracellular uric acid, is the bottom line. How much effect does it have on what's going on in the joint? And I don't know the answer to that. So basically what this decision is going to boil down to for you is a comfort level. If you go on the ketogenic diet, you put your gout in remission, and you find yourself still hyperuricemic, you're going to have to talk to your doctor about this. And then you're going to have to decide for yourself, do I go on allopurinol? Am I comfortable with my uric acid running between 7 and 8, basically for the rest of my life? What do I want to do about that? And unfortunately, and I know this is not what you want to hear, but I don't think there's any good scientific evidence for this right now. And in fact, I would bet if you put 100 doctors in a room, you're probably going to get half of them, maybe more, saying that you should go on the allopurinol, and the other proportion of doctors is going to say, no, you don't need to go on the allopurinol. And that's because we just don't know about this extracellular effect of uric acid. Okay, with that, I don't have any questions in the chat right now. So with that, I'm going to close. Thank you very much for listening to my presentation today. If it turns out you watch this later, because it is recorded and it will be on my YouTube channel, you can feel free to put your questions or comments in the comments below the video. And as everybody knows, on Dr. Pete's Keto Club, I always respond to your questions, usually within 24 hours. And so everybody out there, have a great gout-free weekend. Keep the carbs low. Down the road we go.